Hello and welcome back to Maths Mastery. Today we'll be exploring place value, which is a fundamental concept in mathematics, and it will help us to understand the true value of numbers. So every digit in a number has a specific place, and that place determines its value. So let's say you had the number 35, for example. The 5 in 35 represents 5, while in a number like 256, it will represent 50. So obviously this will make more sense as we go further on in the video, but mastering place value is essential for addition, subtraction, multiplication, and even understanding decimals. So without further ado, let's get started. So in this lesson, we will be focusing on two key learning objectives. So our first is to learn how to recognize the value of each digit in a number by understanding its place value. So this will help us to see why a digit's position changes its overall value. Then we will use this knowledge to compare and order numbers, making it easier to identify which numbers are greater or smaller. So hopefully by the end of the video, you'll have a solid understanding of place value and how it helps us work with numbers more effectively. But what is place value? So place value is used to express the value of digits in numbers. The value of each digit is dependent on the position it has in the number. So this is the table we typically use to represent numbers in our number system. So let's say we have a 4-digit number, 6, 3, 2, 1. And this number reads 6,321. Why? Because we have 6 thousands, 3 hundreds, 2 tens, so 2 lots of 10, and 1 unit. So 6,321. This number reads 6,321. Again, we have the same 4-digit number, and you can think of this in a partitioned version where we have 6 lots of the thousands. So 6 times 1,000 is 6,000. 3 times 100 gives us 300. 2 times 10 is 20. And 1 times 1 unit is 1. So obviously 6 times 1,000 is 6,000. So this is our thousands column. 3 times 100, so this comes from our hundreds column. 3 times 100 is 300. 2 times 10, 2 lots of our tens. This comes from our tens column. 2 times 10 is 20. And 1 unit times 1 is 1. So when you add 6,320 and 1, you will get 6,321 as your answer. Let's look at another example, another 4-digit number. So we have 4,862. So if you look at both 4-digit numbers, they each have a number 6. But does that mean the value of the 6 is the same? Well, no, because the 6 is positioned differently in each number. So depending on where a digit is positioned in a number will determine the value of that digit. So, for example, in our two 4-digit numbers, they both each have a 6, but the value of the 6 is 6,000 in our first number, and here it will be 60 because there are 6 tens in our second number, and 6 times 10 is 60. So because the digits are positioned differently in each number, hence they will have a different value depending on where they are positioned in the number. So for our first number, the 6 is positioned in the thousands column, hence the 6 has a value of 6,000, and the 6 is positioned in our second number in the tens column, hence it will have a value of 60 because there are 6 tens, 6 lots of 10. 6 times 10 is 60. So this is just to reiterate what I just discussed on the previous slide. So the same two numbers, 6,321, it has 6,000s, 300s, 6,000s, 300s, 2 tens, and 1 unit. And our second number, 4,000s, has 4,000s, 800s, because the 8 is in the hundreds column, 6 tens because the 6 is positioned in the tens column, and 2 units because the 2 is positioned in the units column. So let's have a look at these two numbers. So we have 3,245 and 12,341. So I'd like you to pause the video and have a go and see how you would position the digits in these numbers in our table over here. And once you've had a go, we can have a look at these two examples together. Okay, so I hope you've all had a go at these two examples. So let's start with the first number. We have 3,245. So this is a 4-digit number, which means we are only concerned with these columns in the table. We are only concerned with the thousands, hundreds, tens, and the units. Okay, so now we know that. How do we position these digits in our table for this number? Okay, so what we do is we look at the number and see, okay, so this is our thousands column, hundreds, tens, and units. So this should be thousands. So this is TH, thousands, hundreds, tens, and units. And I'm going to write it here just to make it clearer. Thousands, hundreds, tens, units. And I've put a H on this next to the T here to make it easier to differentiate between this column and the other column, which is the tens. There are two T columns. So we have 3,245. Now, do you see why these numbers are positioned in where they are? Okay, so there are 3,000s, 3 lots of 1,000. So imagine we have 3,000 here. This is the value of the 3 in this number. 3 times 1,000 is 3,000. Then we have 200, so 2 lots of the hundreds. So the value of the 2 in this number is 200. The 4, we have 4 lots of our tens, 3,240, 4 lots of our tens, so the value of the 4 is 45. 3,245. And we have 5 lots of our units. So the value of the 5 will just be 5 because there are just 5 units. 5 times 1 is 5. Okay, so when you add these numbers up, you will get 3,245. Okay, so the second number, we have 12,341. So let's use a different color for this number. Let's use blue. Just going to erase. Okay, that shouldn't be. That should still be there. 3,245. And I'm going to use a different color for our second number. Okay, so we have 12,341. Okay, so you may think, okay, it's 1,000 number, so it's 12,341. So you will automatically think, okay, the 12 will go in here, the 3 will go here, the 4 may go here, and the 1 may go here. But in place value, in our table, we can only have 1 digit per entry or per box or per cell. So we can't have two digits in one box or one cell in our table. So let's imagine our 12,000. So let's just put this to one side and think about just the 12,000 part of this number. 12,000 can be written as 10,000 plus 2,000, because 10,000 plus 2,000 is 12,000. So the 12,000 portion part of our number we can write as 1 in the tens of thousands column and a 2 in our thousands column, because okay, that's very big. That's very, very big. I'm going to use red. So this is our tens of thousands column. And I'll go back to my blue. So we have 1 lot of our 10,000s. So 1 times 10,000 is 10,000. So the value of the 1 in this number is 10,000. Then we have 2 lots of our thousands. So 2 times 1,000 is 2,000. So the value of the 2 in this number is 2,000. Okay. So this, oh, oops, sorry. So this here, this part of our number represents 12,000. I keep making, okay, go. Bear with me, bear with me. Okay, sorry for the technical difficulties. So we have, so here, this portion of our number represents 12,000 because the 1 represents 10,000 and the 2 represents 2,000. 10,000 plus 2,000 is 12,000. So imagine when you say the number 12,000. So this portion of our number is the 12,000 part. Then all we're left with is the 341 parts of our number. So 341. So 3 lots of the hundreds gives us 340. 4 lots of the tens gives us 40, and 1 unit. So 1 times 1 is 1. So if we write the value of each digit based on its position in the place value column, so this is 10,000, 2,000. That's very hard to see. I'm going to use a different color. I'm going to use the same color, actually, red. So the value of the 1 in here, it's 10,000. The value of the 2 is 2,000 because the 2 is positioned in the thousands column, which means there are 2 lots of the thousands, which is 2 times 1,000, which is 2,000. 300 is the value of the 3. 40 is the value of the 4. And 1 is the value of the 1 in this number. And when you add 10,000, 2,341, you will get 12,341. And you can even look at it like this. Like when you say the numbers together, 10,200. So the 10,000 and the 2,000 give us 12,000. 341. So it makes sense that when you add the numbers together, you will get our final number here of 12,341. So that's those 2 examples done. So when comparing numbers, so we're now going to have a look at how we can use place value to compare and order numbers. So when we compare numbers, we usually use symbols to denote the relationship between the 2 numbers. So the 2 most common symbols are less than and greater than. So this is less than. So the number on the left will be smaller than the number on the right of the symbol. And this symbol represents greater than. So the number on the left of the symbol is bigger than the number to the right of the symbol. So we have two numbers in this example, 2,345 and 2,317. So this number is a 4-digit number, which means we will only be concerned with the thousands column, the hundreds column, the tens, and the units column. So first of all, we're going to position our digits of each number in their respective columns. So 2,345 and 2,317. So when we want to compare or see which number is bigger between the two numbers, we need to compare from column to column in our place value table. So let's start with looking at our thousands column. So both numbers each have a 2. So we can't really compare to see which number is bigger or smaller in this case, because both digits are the same, i.e. they both have a 2. So because they are the same, we then move on to our second column, which is our hundreds column. And it's the similar case here where they both have a 3 in the hundreds column. So we can't compare and say, oh, this digit is bigger than this one, and vice versa. So we then look at our tens column. So this was our tens column, the second to last. So we have 4 tens in our first number and 1 10 in our second number. So this number has 4 tens and this number has 1 10. So because this number has 4 tens and the second number has 1 10, this will be our highest number because there's more tens in this number than in this number, which means this is our smallest number and this is our bigger number. So if we wanted to write this in terms of using the symbols, we will write 2,345 is greater than 2,317 because both numbers each have 2,000s and 300s, but the differences applies where we look at the tens column where this number has 4 tens, this number has 1 10, and because we're looking for the bigger number between the two, we need to find which of these between is more, 4 tens or 1 10, and obviously 4 tens is more than 1 10, which means this will be our bigger number between the two. So 2,345 is greater than 2,317. But what if you had a list of numbers? So you had more than 2 numbers and you were asked to put the numbers in order from largest to smallest. Okay, so again, all our numbers are 4-digit numbers, which means we are only concerned with the thousands, hundreds, tens, and the units column in our place value table. So if we wanted to put our numbers in our respective columns, so our first number was 4,315, 4,324, 4,253, 4,135, 4,335. So these are full numbers. This is the first number, the second number, the third number, the fourth number, and the final numbers on the bottom. So again, we compare column to column, and because we are looking for which number is the largest, we need to find the largest digit in each column and work accordingly. So let's start with looking at our first column, which is the thousands. So again, all the numbers have 4,000s, in each of their numbers. 4,000, 4,000, 4,000, 4,000, 4,000. So again, we can't actually compare which is larger or smaller because they all have the same value in each of each number, 4, 4, 4, 4, 4. So we can't compare and say this number is bigger, smaller, or bigger or smaller because they all have the same value of 4,000. So we move on to our second column. Largest to smallest. It is largest to smallest. I'm just checking. So we move on to our hundreds column. So we have 3 hundreds here, 3 hundreds here, 2 hundreds here, 100 here, and 3 hundreds here. So we can see that 3 of our numbers have the number 3 in their hundreds column. So let's imagine we want to just put these 2 numbers to one side and just look at the 3 numbers which have a 3 in their hundreds column. So because again they all have the same value in their hundreds column, we can't compare and say this is bigger than this number or this is smaller than this number. So again, we then move on to our next column, which is our tens column. So the tens column has a 1 in the first number, so 1 10, 2 tens for the second number, and 3 tens for the final number. And we can see that out of these 3 digits, 3 is the largest. So this means that this number will be our biggest number, our largest number. So this is the first number, which is the biggest. So this is the first position number 1. And because we've positioned this number, let's imagine we're done with this number because we've already positioned it in order from largest to smallest. So this number is done with. And so then we look at our other 2 numbers. So Again, these two, let's forget, these are not needed for now, and we've done the final number. So we have 1 10 and 2 10s in each of these two numbers. And between 1 10 and 2 10s, 2 is larger than 1. So, which means our next largest would be 4,324. It's the second largest, so 324. I think I'll use a different color. Just so we don't get these mixed up. So we've used this number and this number. These numbers are done, which means the next smallest would be this number, 4,315, because again, they all have a 4, and only these two numbers had the 3 in, which means we only be concerned with looking at the numbers that have the 3 in the hundreds column. And we've done with this number and this number, so we're left with this as our next largest, which is 4,315. Okay, so we can now look at our last two numbers and look at which one is larger or smaller between the two. So again, they each have 4,000s in both numbers, and we can't compare if the numbers or digits are the same. So we look at our next column, which is the hundreds, and we can see this number has 200s, this number has 100s. 2 is larger than 1, which means this number is our next largest. So 4,253 is our next largest, which then leaves us with this as our smallest number, which is 4,135. 4,135. So this is the last, and this is the second to last. So in order from smallest to largest, our first number is 4,335, number 1, 4,324, number 2, 4,315, number 3, 4,253, number 4, and then our last number, or our smallest, is 4,135, which is in 5th position. So, as a quick overview, let's just have a look at our overview for today's video. So that really concludes our lesson on place value. So again, we looked at understanding how place value determines the value of a digit in the number, and also using place value to compare and order numbers. So with place values, it's really all about understanding where the digits, how the digits are positioned along the table, and using that to determine the value of the digit in each number based on where the digits are positioned on the table or in the number. Then we can use that knowledge to help us compare and order numbers like we did in the previous example, where we had 5 numbers and we ordered them from largest to smallest. And we then looked at comparing 2 numbers in the other example. So you can use place value to order and compare numbers from smallest to largest or largest to smallest, depending on the question you're given in whatever scenario. So that concludes our lesson on place value. So hopefully you have a better understanding of how place value determines the value of digits, and how it helps us compare and to order numbers. And if you found this video useful, please be sure to like and subscribe so you don't miss any new uploads, and share to anyone who you think may find it useful. And if you do have any questions, feel free to leave them in the comments below. And thank you for watching, and I'll look forward to seeing you in the next video. Take care and bye!